All right, so I'm moving on to the very last page of the practice test, and these are getting pretty difficult as we go. Looking at number 15, it says Jessica has 2 strings. The first string measures 80 centimeters, and the second string is 64. So I have a string here, and it's 80 centimeters, and the second string is 64 centimeters. She wants to cut the strings into equal lengths. And they want to know what is the length of each string, and then we want to know what's the least number of strings of equal length she can get. So what we're really trying to do is figure out what is the biggest number that can go evenly into 80 and 64. Because if we do that and it goes evenly, then we're not going to waste any of the string. So really what we're looking for is the greatest common factor, or the biggest number that divides evenly. And so the method that we've been working on for greatest common factor is just using our trees. So we have 8 times 10, 4 times 2, and 2 times 2. And 10 can be broken down into 2 times 5. And we're breaking them down into prime factors. 64, 8 times 8, 2 times 4, and 2 times 2. And I'll do the same thing for the other one. So, what we do for greatest common factor is we make a list of all of our prime factors, and we do the same thing for 64. And I had 6 2s. And then we pair up as many as we can. So I have a pair of 2s, actually 4 pairs of 2s. So 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. And what that's telling me is that my string has to be 16 centimeters long. That means that I can cut 80 and 64 into 16 centimeter chunks. And so that's what I want to do. So what I need to know is how many strings am I going to get out of the 80 centimeters? So I'm going to take 80 and I'm going to divide it by 16, and 80 divided by 16 is 5. So I'm going to get 5 strings. So I could kind of cut it over here to make a visual. 1, 2, 3, 4, 5, and they're each 16 centimeters. And we can also do the same thing with 64. We're going to take 64 and divide it by 16, and I end up with 4 16 centimeter chunks. So I end up with a total of 9 strings that are 16 centimeters in length. All right, moving on to the last one. So looking at number 16, this is a bus A takes 21 minutes to complete its route, and B takes 35 minutes to complete its route. If both buses leave the station at 7:30, at what time will they arrive at the station at the same time? And so we really have to think about multiples of these because the number is getting bigger. So 21 minutes, the next time it would hit it is at 42 and 63 and so on. And you can do the same thing with 35. You could do 35 and 70 and see where those numbers meet up, or you can do it using the trees. And so what we're really looking for is the least common multiple. So they can list their multiples or they can do the trees. The trees are a little bit quicker once you get the hang of it. 7 times 3 is 21. And for 35, I have 7 times 5. So I make my list. I have a 3 and a 7, and I have a 5 and a 7. And so for least common multiple, the first thing you always do is find the greatest common factor. And the greatest common factor is 7. I had one pair of 7s, so my greatest common factor is 7. And to find least common multiple, we just multiply by the extras. So I have an extra 3 and an extra 5, and 3 times 5 is 15. So looking at this, I have to take 15 times 7. 7 times 5 is 35. And 7 plus 3 is 10. So what I find out is it is going to take 105 minutes for them to make it back to the bus stop at the same time. So if the last time was at 7:30, because I'm over an hour, I think the easiest thing to do is to go ahead and say, okay, what would 60 minutes later be? So 60 minutes later is going to take us to 8:30. So 60 minutes is going to take us to 8:30. So if I take 105 and I subtract 60, I'm going to end up with 45 minutes left. So I'm at 8:30. So I'm thinking, what if 8:30, what is 45 minutes after 8:30? And it's actually going to take me into 9:15. So it's going to be 9:15